we're going to learn all about how to transform functions. You'll find that you can make almost any of these long, complicated functions you see by transforming a more simple function. So you'll often have something like f of x equals x squared. That's going to be the primary type of function we're going to focus on here, though you can apply this principle to others. So we start with our base functions, and then we have things such as vertical shifts. Vertical shifts. Vertical shifts. How do they work? A vertical shift happens in the following scenarios. We'll have g of x is our transformed function, and it will be f of x plus 3. So there's addition or subtraction happening outside of the parentheses. Again, we're taking our original function and we're adding or subtracting something to it. What does that look like? Well, we'll have a graph here. F of x will be a parabola. And now we have our transformation here. We'll write it in red. It's moving up 1, 2, 3, up 3, and a parabola. So all that's happened is that the parabola moved up 3 units. Allow me to give you another example. G of x equals f of x minus 5. Minus 5. Now, when it's subtraction, you move down the y-axis. So you go 1, 2, 3, 4, 5. And you have the same parabola. Right, so those are vertical shifts. If it's outside the parentheses, it's a vertical shift. That is a rigid transformation, so the parabola stays the exact same. Now, we're going to do one much the same. It's going to be a horizontal shift. We're going to have g of x equals x squared again. Again, almost everything, or really everything we do here is going to be x squared, but it can work with others. So we'll have x squared, and we'll have a transformation, and let me change that. F of x equals x squared. But we'll have g of x equals, we're going to transform our original function to f of x minus 2. All right. Now, what is happening here? Well, when you have, here's your original, a parabola. And when you have a addition or subtraction within the parentheses, you're going to shift horizontally. Now, it's the reverse. This is going to be red, but it's going to be reverse of what you expect. When you see minus 2, what you think you're going to do is move over to the left. No, you're going to do the exact opposite. You're going to move over to the right. 1, 2. There we are. So this is a transformation horizontally, 2 to the right. All right, let's repeat that again. G of x equals, let's give it a new one here. Let's say f of x plus 4. All right, what is that one going to look like? We're going to make it blue this time. What does that one look like? Just said it. We're going to move over to the left 4. 1, 2, 3, 4. Let's say right there. Over to the left 4. And it's a rigid transformation. Our parabola stays the same. All right, so now I'm going to pop up a few examples of problems that involve only rigid transformations. Translations left, right, up, down, so on. Let me write those up here. All right, here's a collection of 3 transformations. I've given you f of x equals x squared, and g of x is a translation or transformation of f of x. Go ahead, do this one for yourself. Okay. So now there's a pattern you need to recognize here, and that's that g of x is a transformation of f of x. Well, in that case, that means wherever we see x minus 1, we know that f, and that's squared, we know f of x equals x squared. So x, this expression is taking the place of this here. Okay, and now it's in parentheses, so we know we're going to horizontally shift. So let's go ahead and give this a try. We have our, well, first of all, we have our original parabola here. And we're going to transform it horizontally. We have minus 1, so that means we're going to move over to the right 1. Remember, when it's in the parentheses, it's the opposite of what you expect. And it is an identical parabola. Okay, shift it over to the right 1. Now let's take on the next one. We have x squared plus 6. This means we're going to shift. We have our original function, and it's in the, we can imagine it's in the parentheses here, and we're going to vertically shift 6. So we're going to go 1, 2, 3, 4, 5, 6 up. We went 6 up, and we draw a parabola that is rigidly transformed that direction. And now for C, we have we combine these two elements. We do what's in the parentheses first, because when we're doing these transformations, we must follow PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Let's do what's in the parentheses. We go up, we go left 3, 1, 2, 3, and we go down 2, 1, 2, and we are right there. Oops, we have an upwards facing parabola. Okay, so that's our vertical and horizontal transformations. Let's move into the reflections. I'm going to focus on one type of reflection. There's two kinds, but I want to focus on one, and that is over the x-axis. We can also flip over the y-axis, but let's save that for a later video. If g of x is a transformation of f of x, and f of x equals x squared, and let's say this here. Let's go boom, boom, and this is f of x, and we want it to get g of x. What do we have to do to f of x? And let me give you g of x. It's going to look like this. Reflection over the x-axis. What do we need to do to f of x to accomplish this? What do you think? I bet you can figure it out. Well, what we need to do is we need to make the entire expression negative. In other words, g of x would equal negative x squared. That is how we reflect over the x-axis. A negative sign flips the graph vertically. And it would be the same if it was negative 2x squared. It would flip and it would stretch. Speaking of stretching, that's what the next example is. That's the next type of transformation you must know, is stretches and compressions. If we have f of x equals x squared, and we want to stretch it, what does that mean, stretch? We start with our original here, and we want to stretch it, meaning we grab it and we pull it up, and it gets tighter, like a rubber band, kind of. Well, in order to do that, what we must do in order to get g of x, which is our stretched function, what we must do to f of x, or x squared, is we must multiply it by a number larger than 1. So this is a stretch by a factor of 2. By factor of 2. Now, we can actually do the opposite with g of x. We can do the exact opposite, meaning we can make it, compress it, make it less taut, so to speak. We can do so by multiplying by a number less than 1. That compresses by a factor of 1/2 in this case. All right, so those are stretches and compressions and flips. Now I'm going to go ahead and give you 3 practice problems for you to do all on your own. And after you do them, I will do them myself. Now remember, all of this is very conceptual. I'm not going into numbers exactly. There's a reason we're just stretching it. It's a little complicated, and you want to understand how it's changing broadly before you try to understand it deeply. Okay, so here's going to be 3 problems I'm going to give you. You're going to transform, say what you're transforming, sketch what you're transforming, and I'll solve them myself and do the same. Okay, now here I've given you 4 problems actually. We start with the given f of x equals x squared, and we make a series of transformations. Each one of these colors or equations represents a transformation. Go ahead, work through them yourself, and then I'll work through them. All right, I'm sure you did a great job, so let me do it myself, and you can check your answers. G of x gives us a stretch, a reflection, a horizontal translation, and a vertical translation. So let's do it in order of parentheses first. So -3 is going to move us to the right 3 units. So let's put, that would be right about here, right about 3 units over, right about there. All right, and we're also given a multiplication. So we're going to flip and we're going to stretch. So we're going to write that in there, flip and stretch. And we're also going to move up. We're going to vertically translate up 1. And so we can erase this. And now our final parabola is going to look about like that. Stretched, flipped, moved horizontally right, and up vertically 1. Let's move on to the second one. G of x equals f of x minus 4 plus 3. This one is just a horizontal translation to the right 4. 1, 2, 3, 4. So right about there. And a vertical translation 3. 1, 2, 3. So right about there. Okay. And this is a upwards opening parabola. That is our transformation. Let's move on to the next one. We have negative f of x plus 2. So that means we're going to move over. We're going to move over 1, 2. Our origin moves over 2. So we're right about there. And it's negative, so it's going to flip it into a downward facing parabola. Okay, and we have one more. This one is going to be a stretch again, and it's going to be a horizontal translation and a vertical translation. So we're going to move over 1 to the right because we have x minus 1, and we remember that it's the opposite when it's in parentheses. So 1, and then we have a stretch, but we also move down 5. 1, 2, 3, 4, 5. So right about there. So we're right about there with a stretch, meaning our parabola gets tighter. Okay, so that was the video on function transformations. These transformations have numbers involved with them as well. That would be a great next topic for you to take on, understanding exactly how when you have a squared function, why when you multiply it by a negative it flips, or when you do +1 on the end, why it moves up 1, and so on. But this helps you understand it broadly. And if this video helped you with your homework or your schoolwork or whatever it may be, please leave a comment, like, or subscribe. See you in the next one.